So I think I'm going to get started. I'd like to introduce the ladies of Beyond Benign, at least some of the ladies. And Ann Lambert is a chem department head and teacher at King Philip Regional High School and certified lead teacher with Beyond Benign. Kate Anderson is the K through 12 director of ed at Beyond Benign, and Janie Butler is the K through 12 program manager at Beyond Benign. And they're going to speak about Green Chemistry PLC, the lead teacher program. And so we're excited to hear you. Thank you.
Thanks for the introduction. I'm gonna try to start sharing my screen, which is always a little bit of a tricky feat.
Okay.
So let's see how.
Go down to the green guy down there. There you go.
There we go. Yeah.
And I need to move
There we go.
this out of the way so I can get to present. Sweet. Okay. Can you guys all see that?
Yeah, beautiful.
Cool. Okay. So beautiful introduction. I think that gave a great summary of what we're going to be chatting about a little bit today. And we're really excited to have Ann with us, the Beyond Benign team, sharing out what it's like to be in the Green Chemistry PLC and what it means to be a lead teacher. So this is just to introduce Kate and I real quick. I wanted to make sure that we had our contact information on here in case people wanted to reach out. You can see both of our emails on here for Beyond Benign. We are also both on Twitter, along with Beyond Benign has its own Twitter and Facebook account. So if you want to connect with us there, we always love that, to hear how green chemistry looks in your classroom, how it could look with your students. If you have any tricks or questions, it's a really easy way to just tweet out. Chem Twitter is a special place. And I also just want to say that during this presentation, if you guys have any questions, please feel free to put them into the chat box. What we've done is we've prepared about a 45-minute presentation for you all, and then we're going to have some time at the end in case you want to hang out and ask us a few questions, so we're able to build that in a bit, have a little bit of a buffer zone. So, yeah.
Yeah, I'm just going to jump in and just say that I'll be posting in the chat with some of the live links. So if you want to follow along with that, that would be great. But really, I mean, we always find our presentations to be much more fun when we're answering questions that you want to get at. So please do join us there. All right, just reiterating that. Thanks, Janie.
Yeah, good point, Kate. I like it. So let's dive into a little bit of why green chemistry, why is it something important? And first from that, we have to start with what is the traditional science education. So traditionally, science education is done in school laboratories, and they can use chemicals that are dangerous and expensive to maintain. So if we increase that level of toxicity, it means that there's more harm towards students, and it also means that there's a higher cost of getting these chemicals and also disposing of these chemicals afterwards. So what's working really well is showing demonstrations to students, being able to show what chemical reactions will look like, making colorful reactions, making things that show demonstrations. But we kind of feel like there's something missing in terms of why can't we do this in a more sustainable way? And so that dives us into green chemistry. That's really what we work on here at Beyond Benign. And so I want to have the definition of green chemistry up here. I feel like a few of you in this group might already be familiar with it, so I'll cruise through this pretty quick. But green chemistry is the design of chemical products and processes that reduce and or eliminate the use of hazardous substances. So to break that down, the design, the creating of chemical products and processes, the products that are being made and how they're being made in a way that reduces that harm, to do in a way that's a little bit more benign. That's where we get our name of Beyond Benign. And one of the ways to think about green chemistry is benign by design. From the inception and when it's first created, it has to be made to thought of how it can reintegrate into the environment and how it can be benign in every stage of its life. So really that design, creating chemicals that are benign is green chemistry. There's 12 principles of green chemistry. 12 is a lot to remember. I like to boil it down into these three big categories of cost, safety, and performance. Ooh, we lost an E on performance, but see if your brain can fit it in. Safety for both humans and the environment. We want to be able to do things that aren't dangerous or hazardous to you or your students. We also don't want it to be dangerous or hazardous to the environment. So we really want it to be a high level of safety. The second is performance. In order for something to be considered green chemistry, it has to have that high level of safety, but it also has to be able to perform at the same level of other experiments, other reactions that are traditionally done. If it's not able to perform at that same level, it's not able to compete and be a competitive solution. The third one is cost. If we're able to do something that's really safe and able to perform really well, but it's super expensive, will anyone do it? Probably not. Money is a huge factor in this. So it has to be able to be done in a way that's cost effective. So these three things really summarize what it means to be considered green chemistry. So that brings in Beyond Benign. Who is Beyond Benign? What do we do? How does this interlace with green chemistry? So our mission is to develop and disseminate resources that empower educators, students, and the communities to practice sustainability through green chemistry. So how can we make materials and resources for a community of educators to use green chemistry in an effective way, in a way that's able to be more sustainable for all of us? And the way we see this happening is that we want to see a world where the chemical building blocks of products that are used every day are healthy and safe for humans and the environment. The way that we like to look at it is that we see that a lot of chemistry can be done using green chemistry, and we hope we get to a point where all chemistry we're able to drop that green is done in a green way. Oops, sorry. So how do we see this impacting students? How do we see this change happening? Well, we want to be able to equip students to be able to understand what's happening out as consumers. We want them to understand STEM and sustainability and why that's interesting, and to foster the adoption of this, of wanting to know what green chemistry is. We see that we're able to impact the students by going to the teachers and making that real change. And we also want to inspire students that there's ways to do things in green chemistry. We've been doing a lot of work in invention education and showing what happens out in industry, and we feel like these are important arms in how green chemistry can be taught. So we see that there's a lot of different ways that green chemistry can be integrated into education. I want to start on a really broad scope and then show specifically what Anne does in her classroom of how this can be in like bite-sized pieces. So how does Beyond Benign do all these lofty goals? How do we develop and disseminate these resources? Well, we try to do this by having things that are at the tangible level. We create experiments, we host workshops and professional development. We do these things through our website and with our network of community. The other thing that we want to do is really foster a community of leaders. We want it to be able to be a place where people are able to collaborate together, and also have a spot where students are able to work together and create more people who want to do green chemistry in both the educational setting and outside of that. Our theory of change is that all of this starts at the K-12 level. If we're able to implement green chemistry at K-12, then we're able to percolate outwards towards higher education in the colleges and universities, and students go there asking questions like, can we do this lab in a bit more of a sustainable way? Do we have to use this much material? Are we able to dial it back? Are there other solutions that we're able to use instead? If they're able to think in that critical way and ask those really important questions, we're able to start changing the system. And that all starts at the K-12 level of students being exposed to green chemistry and learning that there's a different way to do things. From higher ed, we're seeing that once students are trained in green chemistry and able to do more, they're able to change industry and what happens out there. There's actually a lot of push from industry right now to do things in a more sustainable way. So this section works really well, because if we have students who are trained and understand and ask the questions about sustainability, they're able to be really effective in the workplace because they're working on that cost, safety, and performance. Outwards from there, then hopefully we're able to produce more benign materials, processes, and products, and overall change the health for humans and the environment to make it a better place to be. So we hope to advance green chemistry education for a sustainable future through using green chemistry at the K-12 level. So why green chemistry at K-12? What does this look like in the classroom? The first one I really like to start with is equity of access. So thinking about that cost, safety, and performance, if we're able to do labs that have less hazard, that are safer for students, students are able to be more hands-on in their learning and have more access to materials and have more access to chemistry. This ties in nicely with the second one in that orange circle of increasing student exploration and invention. So once they're able to have their hands and understand green chemistry and understand why things would happen, they're able to think, maybe I could change something else, or maybe something else can be reinvented. The third in yellow you see there, I've talked a lot about safety at this point, but classroom safety increases when green chemistry is a component of it. And I've also touched upon the connection to industry. This ties in with student interest, but both of these things, industry and students, are interested in doing things in a more sustainable way, of understanding how they can really change how things were done to do it in a better way afterwards. So students do seem really interested in learning how to do things in a bit more sustainable way. So how do we make these changes in the K-12 classroom? How do I know all these things I've been saying? It's really through the work we do in our lead teacher program. So we work with a team of teachers from across the country. We actually have a few teachers in Canada in our program by now. And so they work in practicing green chemistry. They are in-classroom teachers who utilize this with their students. That's a huge bonus because they're able to implement the labs and understand what's really needed for classroom teachers. They sign on for a 3-year commitment in advancing the field of green chemistry, and they're really leaders in this. They're able to make a lot of change. So the type of work that lead teachers do, they lead presentations, they mentor other students, they write curriculum. All of our curriculum is open access, and it's by teachers for teachers. They also teach students. They understand what green chemistry looks like in their own classrooms. They foster invention with their students, and they're part of this network of green chemistry educators. They're part of our community. So if other teachers or other educators have questions about something a lead teacher has written, we're able to connect you, and we're able to get right to the source and say, would this lab work if I tried to do it this way? And the person who wrote the lab will be able to say, oh yeah, or I do it this way because of this, this, this. So it really is about like fostering this community, having everyone come together. And as you can see, our lead teachers do a lot of stuff. We definitely keep them busy. So I think that's exciting. Ooh, clicking all over the place. So now I would really love to introduce Ann Lambert. Ann was one of our lead teachers, and she is now a certified lead teacher. She'll be sharing her story with you all of how she's come along this journey with us and what it looks like now to be an advocate for green chemistry.
Thanks, Jamie. Let's see. Do I want to continue? Yes, I'm going to switch and share my screen. Slowly but surely, here it comes. Great. Okay, so thanks again. I was really honored when Kate and Janie asked me if I would help with this presentation and be their lead teacher case study. And it was actually a lot of fun to really go back and reflect upon my green chemistry journey that I've had for the past 10 years. And so I'm going to talk a little bit about my journey in these 3 segments here: professional development with Beyond Benign, the ways that some of this has transferred into implementation and curriculum at my school, King Philip. And thirdly, I'm going to talk about some of the amazing opportunities that I've had as a result of being a part of this green chemistry community. So I was first introduced to Beyond Benign in 2009 when I was attending Chem Ed 2009. And I was actually part of a green chemistry, or I'm sorry, of a NEAC delegation that went in 2009. And our group was so excited about the opportunities that we heard about with Beyond Benign that we suggested that our spring meeting be held at the Beyond Benign labs up in Wilmington. and so this happened. Maybe some of you guys were there. And after this, I attended a 3-day workshop that summer of 2010 that was at Beyond Benign Labs. And it was after that that Kate reached out to me and see if I'd be interested in working with a team of teachers to develop some of the replacement labs. And so began my journey with Beyond Benign and green chemistry. Some of the first replacement labs that I was on the development team for include color flame candles, which I'm going to talk about a bit more in detail later, a Sharklet chemistry lab, and some greener chemistry reactions. I'm going to talk a little bit about my involvement with the lead teacher program. And then also I'm going to tell you about some extended opportunities that I've had the great fortune to have because of the networking that started with Beyond Benign. So once these replacement labs were developed with that original team of teachers I was working with, we needed to try them with students. And so my colleague, Rich Boucher, some of you guys might know Rich. Rich and I test piloted several of the replacement labs at my school, which is King Philip Regional in Rentham, Massachusetts. And I can especially remember working with students on that flame emission lab and getting their feedback and their ideas for improvements for the protocols. And so these ideas were then incorporated into final drafts, and that lab is actually one of the ones that's on the website now, the Beyond Benign website. And as Jamie said, I want to reiterate, all of the materials on the Beyond Benign website are open at source, and they are editable documents, so you can make them your own. So I had the opportunity to deepen and further my understanding of green chemistry education and my own repertoire through participation as co-presenting with Beyond Benign at various workshops and mini courses. For example, I helped to lead workshops at places like Stony Brook University, Roxbury Community College, Bridgewater State University, and of course at the Beyond Benign labs up in Wilmington. And additionally, I was on a team of early Beyond Benign teachers who participated as moderators at a webinar that we developed in coordination with the Department of Ecology in the state of Washington. I developed and taught the Advanced Green Chemistry course through Beyond Benign and the Colorado School of Mines. And a couple of really interesting projects that I was able to develop and star, and I'm saying star in air quotes, some videos. And so I was involved in a pause and predict video for Pearson textbooks that went along with the textbook. And I was involved in the creation of an MIT Blossoms video, and I'm going to talk about that a bit more later. So that was one of the really exciting opportunities for me, because being involved in video was a little bit out of my comfort zone. So it was really cool to have a chance to work with a great team to develop some of those new skills. So as Beyond Benign's green chemistry education programming grew, Kate and her team recognized the need to expand this teacher team. And I was one of the veteran curriculum specialists who helped to outline the purpose of the lead teacher program and define expectations. This was a huge undertaking, really thinking outside of the box, and Kate and her team should definitely be commended for how successful and far-reaching the program has become. Janie filled you in a little bit on it already. So I'd like to then go back and take a look at King Philip High School and just talk a little bit about how my experiences with Beyond Benign have helped to drive our curriculum and our programming at my school. As a lead teacher, learning all of these new things, that is a great outcropping that comes out of these opportunities. So as time went on, Rich retired and my school grew and my team of teachers expanded. And so I encouraged my new colleagues to take the Beyond Benign Intro to Green Chemistry online course a few summers ago. And they did that. And since then, we've essentially revamped our programming so that green chemistry is woven throughout it. Now, as all of you high school chemistry teachers know, that's not an easy task because we can't just adopt a standalone green chemistry curriculum. We have to figure out ways to weave those concepts throughout our DESE standards or NGSS standards-based curricula that we are required to be teaching. So, however, really once my entire team of teachers had embraced this idea, it became an exciting and collaborative initiative. And so as part of the presentation today, I'm just going to give an overview of some of the activities that we've come up with. Maybe it'll give you some brainstorming or some jump starts for some things you might want to do in your school. So before I do that, I want to first give a special shout out to my colleague, Cara Diorio. She's been quite a leader in the development of many of our activities. And a few years ago, Cara took the Beyond Benign Advanced Green Chemistry course, which I just happened to be teaching. And so I saw the amazing things she was developing. And so many of the lessons that she developed during that course have become the foundation for our curricular activities and even beyond King Philip when I talk about some of those extended opportunities. So as noted here, this of course doesn't happen overnight. It was over a period of several years that we continued to incorporate activities, lessons, then you know how it goes. We reflect on the outcome, tweak to fit our culture and our students. And so because of that, I also want to give an additional shout out to the other two members of my chemistry team, my colleagues, Kristen Doss and Elizabeth Hawking, because the development of our green chemistry curriculum has definitely been a team effort. Many of the activities that we have incorporated are either straight from Beyond Benign or they were Beyond Benign inspired lessons. So we start off the year by teaching our students about the 12 principles right away. And we use an activity called the 12 principle matchup that was actually inspired by one of the Beyond Benign middle school lessons of the same name. And as I said, it's all of their materials are editable, so it's really easy to tweak it to fit your needs. The format that we use is actually available on the MIT Blossoms website, which I'll discuss in a while. One of the main components of Beyond Benign's initiatives with higher learning, Janie was talking about that a bit, with the green chemistry commitment, is that undergrads are required to take at least one course in toxicology. So as such, with this, we've decided we introduce our students to toxicity, okay? Now, certainly not at the biochemical level, but we use articles such as Chem Matters, How Toxic is Toxic. We teach the students about LD50. We teach them about the GHS system and how to read a safety data sheet. And then we relate every single lab back to the 12 principles. Starting when we teach our students the school lab rules at the very beginning of the year. And so for this activity, teaching the school lab rules, we have each student relate one of the lab rules to one or more green chemistry principles. They make some posters, and then these are posted throughout the classroom. And so on this slide, I actually have, this is what the components of this little worksheet that we've put together have. So in their instructions, it tells them they've been given just one of the lab rules as a broken out, and they're asked to think carefully about it and decide which of the 12 principles would best relate. And so this one I just picked is the lab rule that has to do with disposal. So this student would have this one lab rule, connect it to one or more of the principles, and then they would sketch a little picture of what that would look like. They share these and we hang them up around the room as a reminder. As you can imagine, all of our lab activities are greener replacements. However, we always discuss those traditional methods so students can analyze for comparison. After establishing this green chemistry focus as the foundation for our labs all year, we weave the green chemistry through every lab activity as part of the lab report. So our students will write a traditional lab report. You'll We're all familiar with those, you know, materials, purpose, methods, etc. But our final component we call the green chemistry connection. So with this connection, students will have previously researched the SDS of any chemicals that have been used. They're going to consider the actual methods used, the equipment used, and the teacher will lead a class discussion or direct students to a video that will illustrate the traditional less green methods. And then students will analyze the traditional and the replacement method with regard to the 12 principles. And we found that frequently students will focus on the principles such as inherently safer chemistry, accident prevention, atom economy, energy consumption, those types of things. So they kind of pick a few that they use a lot, but that's fine. As you know, some of the principles are more really geared towards industry. So we find that by having students do this, they really scaffold and embed a personal concept for those principles that they can relate to. The lab activities that we have themselves are fairly standard. So as I mentioned before, we've got to teach these standard-driven courses, and many of the changes that we have are subtle. So I have just a couple of ideas here. For example, students will use hot plates rather than Bunsen burners when heating for something like a calorimetry lab or a dehydration lab. For this type of replacement, students often identify Principle 12, inherently safer chemistry for accident prevention. Students might also consider the energy expended to complete this type of activity. And it's really exciting when they start to contemplate this and they start to realize these aren't always easy answers. And so sometimes a student might, for this type of change, identify Principle 6, design for energy efficiency, as their connection, pointing to the fact that the hot plate is at a lower temperature than the Bunsen burner. However, another student might alternatively justify that more energy was used because it took longer to complete the process. So this is pretty cool. We have not done an energy study ourselves, and of course it would change student to student, I'm sure, as well. So we believe the main point is that the student is thinking critically about this, and as long as what the student is justifying for the application makes sense, then of course we'll accept that as an answer. Another quick idea, we use household chemicals or the lowest possible concentration of solutions whenever possible. And so, for example, rather than using chemicals to analyze exothermicity of reaction for calorimetry, our students would instead use heat transfer using a reusable metal cylinder, and they can use that to study specific heat. And another example, we use Epsom salts, which is magnesium sulfate heptahydrate, instead of traditionally used copper sulfate pentahydrate for things like a percent composition or an empirical formula lab. And an additional interesting inquiry that sometimes emerges out of this is if you have pharmacy grade actual Epsom salts instead of lab grade magnesium sulfate heptahydrate, you sometimes don't get the expected mole ratio exactly. And so this leads to an interesting conversation with students about quality control and things like that. And so for these types of replacement ideas, students have noted things like Principle 4, designing safer chemicals, the number 6, energy efficiency, because of using the hot plates instead of the burners, or maybe 12, safer chemistry for accident prevention, those types of things. So I had mentioned this flame emission replacement lab and said I was going to talk about it a bit more. This one is a really fun one for me. Of the picture on the left, of course, you see traditional flame emission images here. We've got the Bunsen burner going, put different salt solutions in it, you get that burst of color, or maybe even in a petri dish having some of the salt and some sort of alcohol or something to burn that, which of course then we have some issues there where we have an increased risk with using a Bunsen burner. Certainly having a petri dish of salt with some sort of alcohol there. And with these types of demonstrations or lab methods, you're going to end up with more volatilized chemicals in the air. So With the replacement lab, we used the color flame candles, and so that's the picture on the right. This lab is really it is really a true inquiry lab for students because they have longer to look at the color, and they use emission diffraction film that you can get from Flynn. They can also use spectroscopes, and they can analyze they can see the different emission spectra coming out of the colors. And then there's a website, we refer them to the Web Minerals website, where they do a match. And this lab is on the Beyond Benign curriculum, so you can find all that information, the website and stuff. And so it truly is inquiry because, of course, year to year, batch to batch, the candles change a little bit. So the bottom line is, again, the student justifying their selection of what the element that's in the candle is. And so I'm sharing with you here one of my students' actual green chemistry connections for the flame emission lab. So I'm just going to read it real quick. The original lab was not as safe as the one that was performed in the classroom. Principle number 12 was not followed because the Bunsen burner, which is a whole lot more hazardous than birthday candles, this is a student writing, was used. The Bunsen burner had a larger and more powerful flame, which could have given severe burns to those during the experiment. In addition, principle number 1 was not followed because when the different salts were burned, chemicals were released from them. This released waste into the air was a danger for those who spent too much time in the room. And I will throw in there a little anecdote, I'm sure I've told my students too, is I'll get a little bit of asthma once in a while. And so it used to be when I did that old method, I would always be struggling with some asthma on that day. And since switching to color flame candles, I do not have that problem. So that's a nice little side effect for me. So another thing that we do at King Philip, in addition to the ongoing focus on green chemistry application through our lab activities and the green chemistry connection, our students will complete a self-selected long-term project that incorporates green chemistry and sustainability. Students will select a consumer product that becomes the focus for it's a 2-term project. And during the first term, the students do background research on their class of product. And this gives us, as the teachers, the opportunities to introduce them to the concept of life cycle analysis and cradle-to-cradle design. Now, if you're not familiar with either of those, never fear. There are lessons about these concepts on the Beyond Benign website, as well as the MIT Blossoms PBL I'm going to talk about. We teach our students how to identify if their product is open or closed loop with regard to life cycle. Now, I know you're probably thinking, oh, this sounds like it would take a lot of time out of the curriculum, but it really doesn't. We break these up into little mini lessons over a period of time, and then we have our students, for the most part, write their papers as an in-home project. It's done at home. The second part of the long-term project is that students design and conduct their own experiment, and this experiment is directed to have one of these 3 focuses here. So the student could base their experiment on an efficacy study where they compare a traditional product to a greener replacement. So for example, maybe a traditional ammonia-based window cleaner versus, the green alternative or some green or something like that. They could do a toxicity study, so they could test their product on something like maybe seeds or something like that. Does it affect the germination? And their third option is they could do a green chemistry study and develop an experiment that tests its alignment to a particular green chemistry principle. So now coming back to those extended opportunities that I've had the amazing, great fortune to have because of my beginning work with Beyond Benign and then the network working beyond that, I'm going to talk a little bit about this MIT Blossoms project. Elizabeth Murray and Dick Larson are the directors of the program, which is through MIT. And Blossoms videos are available, they have many areas of STEM. They've been created by both high school teachers and professors of higher ed, and they have a worldwide audience. So in 2016, Elizabeth reached out to Beyond Benign to ask if they could work together to create a video based on the Beyond Benign lesson, Writing the Principles. And so this activity is, of course, in the online Beyond Benign curriculum, and it guides students through an inquiry activity in which they will develop the 12 principles, and they're doing it by making some homemade glue. Molly and Wright, I have to give another shout out. I never did any of these things on my own, by myself. Molly and Wright, who was with Beyond Benign at the time, and I wrote what's called a pseudo script, which is a script outline, but not something I had to recite word for word, which was really nice. And that was all under the direction of Elizabeth. And the video was filmed on site at the Warner Babcock Institute and Beyond Benign labs. And so from that, it turns out that this Writing the Principles Green Chemistry video has been one of MIT Blossom's most downloaded video lessons. And so 2 or 3 years ago, the team decided to expand their programming to include project-based learning lessons. Elizabeth contacted me to see if I would be willing to work on a follow-up project. And so, you know, I always like to work with somebody. So I brought in my King Philip colleague, Cara Diorio, who I mentioned earlier. And the two of us developed a 2-part PBL, and it actually just launched this summer. So we're really excited about that. The PBL incorporated Beyond Benign inspired and King Philip inspired activities. And it has 2 parts, could be one or the other or both, you could do. Part 1 teaches that life cycle analysis that I talked about with relation to chemistry and material science. And part 2 involves a biomimicry-based project in which students develop a product using something called Ecovative, which I'm going to talk about in just a second in case you're not familiar with it. It's a mycelium-based material, and they compare their product to a traditional product. The Ecovative project that we developed was based on a lesson that I have been doing with my Boston Leadership Institute students, and that'll be the last extended opportunity that I'm going to talk about today. So this is what, if you're not familiar with Ecovative, this is a company that has developed a method to use agricultural waste to develop packing materials among other uses. They've been used for artwork, etc. So if you look it up, Ecovative or mycelium materials, and so you can buy a pack. It's a DIY activity. It's called Grow Bio. You get this agricultural waste, and you reactivate it. And students mold it, and it grows this mycelium product. And so on the right, you can see some actual Ecovative final packing products. This is being used. So this is one of those industry examples Kate or Janie was talking about that's so cool. Students can actually see somebody's creative green idea in use. I know IKEA is using this for their packing, and there are others as well. And so this is a 100% closed loop. It's biodegradable and compostable. So a pretty cool activity for students. So my last extended opportunity is the Boston Leadership Institute, which is a summer camp for students. And so BLI has grown to actually now they have several campuses in the greater Boston area. I've taught a 3-week green chemistry research course there for about 5 years. And it's a really cool active opportunity. It's a really cool program. It draws from students from across the US and actually across the globe as well. An international student base comes. And I developed my curriculum for this 3-week course based upon Beyond Benign and everything that I've learned there, and many of their activities were incorporated. And when Jane Bybee, who is the co-founder of Boston Leadership Institute, actually reached out to me years ago, would I be willing to do this? I said, if I can make it be a green chemistry course, and they were all for it. So that's been pretty amazing. So as you can see, the wonderful experiences that I've had with the Beyond Benign team have greatly influenced my teaching. They've opened up myriad exciting opportunities. So this is what, you know, with my case study, talking up joining the green chemistry PLC. It's an amazing community. Frequently, and this is really the icing on the cake, frequently my students have told me that it's the passion and focus for green chemistry that's infused into the lessons that helps to tip the scale for them to make the decision to pursue chemistry or engineering or pursue material science for their future endeavors. And of course, we all know that's what it's all about. So thank you for letting me take the time to share my story. And I am going to hand it back to Jamie.
Sweet. Thanks, Anne. I think that's so impactful hearing everything you do and just the reach you're able to have. It's really, I think, exciting. Okay. I'm stealing the screen back from you. Does that work?
I see it.
Okay, so a big thank you to Anne. I think it's just a great story of how it's changed over time and the work that you do now advocating for green chemistry education. So Anne is a really fantastic resource in case anyone has more questions for her or they want to understand what it's like to be within the program. So now I'm going to dive into a little bit of more specifics of where things live in our site. I'm going to go through this pretty quickly, and I'm going to just recommend that you check out our site, beyondbenign.org. But as Anne had mentioned, all of our labs are open access, free to download in Word documents, and I just want to show you where things live. So this is what our homepage looks like on Beyond Benign. From here, you can see that there's an About, K-12, Higher Ed. We do work in both K-12 and Higher Ed. We have a news section where we talk about what's happening out in our community. We have a curriculum specific tab. This is embedded under K-12 and Higher Ed, but also we just want to call that out. And we have professional development opportunities. You can see the events that are happening there in case you want to reach out and connect with us more. So underneath K-12, if you go to green chemistry curriculum, you will get to a page that looks like this. You can see that we have elementary, middle school, high school, and higher ed curriculum. All of these things live all together. Few of our high school curriculum topics, you can see them in all of these different boxes. If you scroll down under that high school curriculum, if you click that high school button here, click, then you go here, boxes, and you can see all the different things that are within here. There's project-based learning. You can talk about solutions, how you invent with green chemistry, what gases are. So you can check that out if you want to go through specific topics. If you continue to scroll on this screen, you'll get to a curriculum summary, which you can download as a PDF. And in here, it has an outline of all of the lessons that are within each topic. It took me 3 screenshots to just capture this, so I'll show you what it would look like. Here are some of them. Here are some more. And finally, here's at the bottom of the page. A few of the teachers have told us that that's one of their favorite ways of exploring around the website, being able to get to everything, to see it all in one spot. Because what we think is really cool is if people even just try one new green chemistry lab, or if they're willing to add in an essence into when they talk about safety. And, you know, it all starts with little steps. So we hope to help you out in that regard. So that's our website. If you guys have any questions about that, feel free to ask. You can put them in the chat, but yeah, check it out. Hopefully it won't be that hard to find it. So Anne did a great job talking about what lead teachers do. Anne also just goes above and beyond and is amazing in everything she does. But I just want to recap that our lead teachers do a lot of different things. They present at conferences, they mentor other teachers, they write this curriculum that was on the site. So the teachers have helped create all of that. They implement it in their classrooms with students. They foster these inventive ideas. I loved that line that Anne had at the end. I tried to even write it down. But like the passion and focus in green chemistry makes the students want to learn all the more. I think that's amazing. And then finally, in this bottom orange circle of this community, of being part of this like professional learning community and what that means to have each other and be able to rely on one another. I feel like that's something we're learning is more and more important while we have to go virtual and be apart from one another, is really coming together and connecting. So a big thanks to NEAC for having us here and letting us connect with all of you. So just a real overview of what the impact of the lead teachers has. They go from all over in cultivating these communities of change, connecting with regional industries or universities or student groups, And this is just in the hopes of broadening the reach of teachers who are exposed to green chemistry, really fostering this community so we have more and more people. And this is what we've tried to do in the last 4 years. And finally, our theory of change. This really all comes back down to K-12. You guys are at the epicenter of this change, of being part of the students' learning so that they can see how green chemistry has a role, how green chemistry can fit in, and how this can be a mindset when looking towards the sciences. So how can you join into our professional learning community? How can you join this community? A lot of different ways. All of our labs, as I said, are open access on our website. So you can tweet at us, you can post on Facebook of you trying out a lab. We'd love to see that. Expect us to slide into your DMs afterwards. We really love to see what it looks like with students. So that could be a neat starting point. If you're really enthusiastic about this and you've been practicing green chemistry with your students, I invite you to apply for our lead teacher program. You can also, we have online course offerings. We have online courses. Normally we host them during the summer and we're hosting them during the fall. Additionally this year, we have an intro and an advanced course that are online. So if you really want to learn more about green chemistry and get into the nitty-gritty, I recommend that. And you can sign up for our newsletter. On our website, you'll see that you can do that. I think Kate will also send a link. But then you can know what we're up to, what's next on the docket for us, and what works into your schedule. If we have a new curriculum released, if you try it out and you're like, oh, I have some questions, you can reach out and let us know. If you see we're doing some virtual PD, please feel free to join. We really love to see faces time and time again, and we feel like that's what makes this community really strong. I'll pause here in case Kate has anything to add before I wrap up.
Thanks, Janie. I know what I did just also put in for sort of another, since I had put the links for the online course and all of the great, other ways to connect with us. And this is something we're honestly still exploring, but, because we're a nice, tight, small group today, there is an opportunity to connect through what is called the Green Chemistry Community Connections, and or it's just Green Chemistry Connections. I think I might be adding a C in there, because I want it to be a community, which it will be. So we can add another C, why not? But so I did put a link in there, and the first one is kicking off today, and it is, at the moment it's primarily faculty, but as Janie had mentioned, like this is certainly one of the strengths of Beyond Benign, is that we've got great connections with both faculty, higher ed, and with K-12 teachers. And so it's really beautiful to see when you can have teams of teachers working together. There's some real magic that happens there of digging in a little bit deeper and figuring out, how it's going to work at both levels. So I'll just sort of plop that, I'll drop that there for you. And yeah, I guess if there's any other questions or thoughts. I mean, I know Esther also just took the advanced online course. So I don't know if Esther wants to say maybe 30 seconds, about what you valued and took away from the advanced course this summer.
Well, it was a great review for me. See how much the program has increased in 10 years is incredible. And I'm now ready I have the great excuse. We have a new building in school that is completely green. So they had no way to tell me, no, you cannot add any of this. So I wrote a grant, got the materials, I'm ready to go. Allow me to review everything and actually start writing the new curriculum for the lessons for this year. So, and 3 college credits on top of it, needless to say, that's just amazing. It's really worth it. And then you talk to other people, you share ideas with the other students. It's just a fantastic, fantastic class. Yeah.
Thank you, Esther. I appreciate it. It always is best if we hear directly from you and people who have, done and gone through the experiences. Yeah. So awesome. Any other questions?
Okay, great. We can also put in the chat our contact information in case people want to reach out more. I just want to circle back and give a big thank you to Anne for sharing her story, for sharing her secrets to her classroom, her secrets to success, and all the work that she's done with us to really advance this field of green chemistry education. I love hearing your story. I think it's really impactful and powerful. So thank you for being willing.
You guys are the base, that's for sure.
Thank you. And a big thank you to NEACT for being willing to have us, to let us chat here, to give us this platform. It's been an interesting summer with all the virtual conferences, but a big thank you for hosting this and inviting us in. So, and thank you to everyone who tuned in and watched it. You know, I feel like I've said the word community a lot by this point, but it is really, all the parts of the community are really important for coming together and making this change happen. So thank you so much, everyone.
Stay connected.
Thank you very much. You can stop sharing your screen now, I think.
Sweet.
So there you are. Okay. Mel's going to take care of the closing of this meeting, but it was so nice to see you guys again.
Thanks, everybody. And if there are more questions or are questions, please ask. I think there have been a lot of chat items. Thank you, Kate, for putting in all the links. So I'm sure it will help everybody else. Any questions? I have some background noise here.
Thanks, guys.
Yeah, thank you so much.
Thank you. Thank you.
I'm gonna botch this name, but Rosine, I don't know, I'm Irish enough, I should be able to get it. But
Rasheen.
she had to head out early, so I think she just left her computer on.
Oh.
Yeah.
Got it. All right.
Okay, thank you so much, guys. I'm gonna head out.
Thanks, Matt. Thank you, Janie. Thanks, Anne. Anne, do you want to pop on a quick?
Yeah, I'm gonna say, you guys wanna do a follow-up quick?
I'll send it.
Yes.
To our other one? Okay, all right. Thanks,
Great.
Mel.
Thank you, Mal. Take care.